Hello, in this video, I'm going to explain a set of rules for calculating uncertainties. Say we have two quantities, A with an uncertainty of 0.03 meters and B with an uncertainty of 0.02 meter. If we calculate S equals to A plus B, then the uncertainties in A and B are going to add up to be the uncertainty in S. So S is calculated to be 4 plus minus 0.05 meters. If S is A minus B, the uncertainties in A and B are still going to add up. Whether you are adding or subtracting two quantities, the uncertainties are always going to add up. This because 0.03 minus negative 0.02 gives us the positive error of 0.05, whereas negative 0.03 minus the positive 0.02 gives us the negative error of negative 0.05. What if S is equals to 2A minus 3B? 2A is simply A plus A. So the uncertainties of A is going to add up 2 times. And minus 3B is simply minus B minus B minus B. So the uncertainties in B is going to add up 3 times. Let's move on. Say we calculate a quantity P equals to A times B. What's the uncertainty in P? It's not going to be this plus this. The units are not even right. But this times this is also not going to be correct. Turns out, if we consider fractional uncertainties instead, we get a very simple rule. The fractional uncertainty in P is simply the fractional uncertainty of A and B added up. And it kind of makes sense, because if A is increased by 1% and B is increased by 2%, then A times B is going to increase by roughly 3%. Once we have obtained the fractional uncertainty, we can calculate the absolute uncertainty. What if P is A squared B to the power of negative 3? A squared is simply A times A, and B to the power of negative 3 is simply divide by B, divide by B, divide by B. So the fractional errors in A is going to be multiplied 2 times, while the fractional errors in B is going to be multiplied 3 times. What if P is equals to 5A squared B to the power of negative 3? The factor of 5 is not going to affect the fractional uncertainty in P in any way. This is because when we multiply delta P by 5 and we multiply P by 5, delta P divided by P is not going to change. So in summary, if something is calculated by summing up terms, we are going to add up the absolute uncertainties, and the coefficients provide us with the scaling factors. If something is calculated by multiplying up terms, then we are going to add up the fractional uncertainties, and the powers provide us with the scaling factors, and we are going to ignore the coefficient. That's all. Ta-ta!